Hi guys. In pursuit of sharing technical knowledge and just to gear up the new generation of engineers, myself Pranav is here to deliver today's presentation, Power Transformer Part 37. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with online tap changers, conceptual factors. To maintain load voltage within permissible limits, every power transformer is effectively designed with on-load tap changers for voltage controlling and regulating system. Both off-circuit, that is OCTC, and on-load tap changing, that is OLTC, equipment must have to comply with IS 8468-1 or IEC 60214-1. On-load tap changers are the most important equipment used in the power transformers whose performance requirements are determined by the certain factors. One, requirement of voltage regulation, range of percent voltage variation, number of steps, percentage impedance of transformer at maximum voltage and minimum voltage tap positions in case of parallel operation with existing transformer and other control schematic requirements. The present grid system is highly integrated through HVDC applications in the present context rather, as well as comprehensive use of phase shifting transformers, that is regulating transformers. As of the industrial load with its variable fluctuation of voltage configuration is of the usual factor that has to face the existing grid system. So more emphasis on regulating the power transformers would have been the prime operating phenomena by deploying most reliable operating equipment like OLTC. Voltage regulation range, so far been made through online tap changers, is typically plus minus 10% of the line voltage in 9 to 35 steps and has to operate 10 to 20 times a day. Most of the power transformers above 10 MVA rating are thus to be recommended for incorporating on-load tap changers as a means of voltage regulation. However, performance requirements of OLTC as well as their routine and type tests are categorically mentioned in IEC 60214-1. Specification, requirements and selection criteria of OLTC, including their types, fittings and accessories, etc., are to be categorically mentioned in the application guide of standard IEC 60214-2. For comprehensive selection of OLTC specifications that would have to configure in accordance with the detailed parameters of the transformer were to be fitted. Control scheme and drive mechanism of OLTC are also to be precisely designed as per the site operating conditions as well as customers' requirement. During the operational sequence of OLTC, the most significant concerning aspect is mainly confined within the changeover selector recovery voltages. So, the manufacturers should have to specify the exact value of the power frequency voltage which would have to appear between opening and closing contacts of changeover selector. Calculation of the recovery voltage that should have to be verified by the online tap changer supplier on the basis of main winding capacitance value as furnished by the transformer manufacturer. There are two types of mounting arrangement of online tap changers. One, in-tank OLTCs, that is, the majority of the quick action resistor type OLTCs are installed inside the transformer tank, in-tank OLTC. And number two, externally mounted online tap changers immersed in transformer mineral oil. Slow action reactor type OLTCs are mounted in a separate compartment which is normally welded to the transformer tank. Basic switching principle and comparative study of reactor type and resistor type OLTC. As because of certain voltage difference between the adjacent taps, so there will be a flow of circulating short circuit current IC when the transformer operates in the bridging position. See figure 128. As of figure 128A, a reactance type tap changer has a special design where the circulating short circuit current is thus to be limited by adopting a mode of preventive auto-transformer, that is a reactor. As of figure 128B, in resistor type of tap changer, where the task of limiting the circulating short circuit current is to be done by a pair of plain resistors. Preventive auto-transformer is an air gap core reactor which has to prevent two adjacent bridge taps from short circuiting. Transition impedance, as in the form of preventive auto-transformer, that has to limit the circulating current for the period when both taps are used. Now see the diagram. Basic switching principle: make tap 2 before break tap 1 using transition impedance. One is reactor principle, that is using preventive auto-transformer. Another is transition resistor principle. Preventive auto-transformer winding that has to act as the diverter impedance, which also serves as a current limiting device while the load tap changer is sitting on or passing through a bridging tap position. Again, I repeat, preventive auto-transformer winding that has to act as the diverter impedance, which also serves as a current limiting device while the load tap changer is sitting on or passing through a bridging tap position. Under normal load conditions, equal load current would thereby flow in both halves of the reactor windings, and the fluxes that may have to balance, rather balance out, giving no resultant flux in the core. The voltage between the taps would have been the step voltage that normally lies between 0.8% and 2.5% of the rated voltage of the transformer. As of the typical internal configuration, most of the reactor type tap changers in the United States of America have 33 positions, going from 16 lower to 16 raise, with the neutral position marked as N, having total of 32 transition operations from one extreme to the other. However, the use of a center tap inductor or auto-transformer as the transition impedance has some advantages over the high-speed resistor type. A reactive type OLTC uses a preventive auto-transformer as a bridging reactor that is designed for continuous loading and can have to use the bridging position as a service position. Whereas a high-speed resistive type OLTC uses a pair of resistors to limit the circulating current during the operation of a tap changing and never be used at the bridging position as a service position. This is the difference in between reactive type OLTC and resistive type OLTC. In reactance type tap changer, high circulating currents are therefore to be diverted by using a diverter switch where a dedicated preventive auto-transformer winding has provided to function as the diverter impedance. As the preventive auto-transformer winding would have been designed for continuously rated, so any sudden failure of auxiliary supply, while just at the very moment of change of tap, that would not necessitate the main transformer being taken out of service. In that situation, the intermediate or bridging position can be used as a running position, giving a voltage equivalent of 1/2 tap step. But the resistor transition tap changer, whose transition resistors would have made to design with a finite time rating, as because of handling the high power dissipated when transition resistors are in circuit. Perhaps there might have been a certain risk of damage if a tap changer has failed to complete its cycle of operation. So, there might have been incorporated some form of additional energy storage system in the driving mechanism of the resistor type tap changer to ensure that a tap change process, once initiated, must have to be completed its total cycle of operation irrespective of failure of auxiliary supply. As the earlier version, the stored energy mechanism was entrusted through a flywheel, and the process of tap changing was to be a low-speed operation. However, in the latest technology, that mechanism has been totally superseded by the introduction of using springs for energy storage mechanism, and the version has also been changed to high-speed resistor type tap changer. So, the total time span that a resistor is in circuit during a tap change process would thus have become limited to a very short period. In reactor type tap changers, the basic advantages are so far been exhibited that the circulating current between the taps during the bridging condition would relatively be associated with low power factor, and that being adversely affecting the diverter switch contact life. The preventive autotransformer winding itself has a costly item and would have to occupy a significant amount of space in the transformer tank. The midpoint reactor type of tap changer has configured with large number of tapping positions of having small tap steps and is capable to use the bridging position as a running tap. As of the design, the total range of regulation and the size of individual tap step is most often specified as plus minus 10% voltage in 32 steps of 5 or 8% voltage per step. Underneath components of the tap changing circuit together would have to perform in a perfect sequence so that the transformer load would never be interrupted during a tap change operation. 1. The preventive autotransformer that provides the switching impedance. The tap changing number 2, the tap changing module that has to configure with top selector and reversing switch. Number 3, the load switching module that consists of the bypass switch and the vacuum interrupter. The tap changer must have the sequence of opening and closing of its various switches and selectors such that the load current has only to break inside of the vacuum interrupter. Again, I repeat, the tap changer must have the sequence of opening and closing of its various switches and selectors such that the load current has only to break inside the vacuum interrupter. Introduction of vacuum switches would obviously enhance the life of the contact tips, but for which a definite limit to the safe working voltage that should have to be maintained when interrupting circuiting currents. Once the high-speed resistor type tap changer has been introduced, the operational reliability has been greatly improved as because of entertaining a new version of driving mechanism with having the close association of precise switching mechanism. The copper tungsten alloy would have been the basic material of new version of the arcing tips. Consequently, designing in associated with a complete change in switching philosophy to have a short arcing time that has also brought about a substantial improvement in contact life. The high-speed resistor tap changer would have been gleefully accepted by most of the transformer manufacturers due to its compactness and lack of wear of diverter switch contacts as because of the high speed breaking where the circulating current is at unity power factor. The expected contact life would have been exhibited usually of the order of 25,000 number of operation, whereas in case of reactor tap changers, the contact life is of the order of 10,000 to 20,000 number of operations. From the reliability survey and a statistical analysis, following points are to be categorized as regards to resistor type versus reactance type tap changer. Resistor type OLTC is of much suitable for high voltage while it requires high speed switching mechanism 50 to 150 milliseconds, and reactor type OLTC is suitable for limited range of voltages, though it can sustain higher load and allows a longer transition time. That is higher current. It can withstand, it can sustain. Fast acting switching sequence of resistor type OLTC can have to handle higher voltage but not high current. Slow acting switching sequence of reactor type OLTC has the difficulty to break the circulating reactive current, and this will have to rather limit the step voltages, but subsequently it can handle relatively high current. In accordance with these principles, resistor type tap changer is being usually located on the high voltage side of the transformer, whereas reactor type tap changer is being usually connected on the low voltage side of the transformer. The reactor type tap changer, the rated position of tap selector is normally at the mid position, and as the superimposed circulating current between the two involved tapped is small, so the transition reactor can be left permanently in short circuit between them. Let's stop here. Further to be continued at later stage. Thank you for listening the video. Kindly do like, share and subscribe. Your subscriptions would encourage to post more videos. Also share your comments or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section. Thank you. Thank you for patient hearing.